So friends, here are some questions for the number system. So this is the basic level quiz. So these are some more questions to be done. Now let's look at the solution for these questions. The first question says, the product of two whole numbers is 17. What is the sum of the squares of their reciprocal? So now, since we know that 17 is a prime number, so the only two possible numbers whose product it could be are 1 and 17. Now we need to find the sum of the squares of their reciprocal. So we are saying we need to find out 1 by 1 square plus 1 by 17 square. So this comes out to be 1 plus 1 by 289, which is 290 by 289. So let's move on to the second question. We need to find the units digit in 3 raised to power 3 plus 16 raised to power 4. Now, to find the units digit of this sum, we'll need to first find out the units digit of the two terms of this sum. So 13 raised to power 3, we'll find the units digit of this. Then we'll find the units digit of 16 raised to power 4, and then we'll add them to find the units digit of this sum. So to find the units digit of 13 raised to power 3, we need to find the units digit of 3 raised to power 3, which we know is 7, because we said 3 raised to power 3 we know is 27. So the units digit is 7. Similarly, units digit of 16 raised to power 4 is same as units digit of 6 raised to power 4, which we know is 6, because 6, if we look at 6, 6 raised to power 1 is 6, 6 raised to power 2 is 36, where again the units digit is 6, and if we continue to do that, 6 raised to power any number, the units digit will always remain 6. So we know the units digit here is 7 and the units digit here is 6. So to find the units digit of the sum, we'll add the units digit, and the units digit of the sum becomes 13. The units digit comes out to be 3. Let's now look at the third question. A 3-digit number 3A5 is added to another number which is 933 to give a 4-digit number which is 12B8. Now this number is divisible by 11 and we need to find out A and B. So let's first add 3A5 to 933 and we get the result, which is 12B8. Now since this number is divisible by 11, we can say that if we add the even and the odd and we subtract from them, so we add 8 plus 2 and we subtract b plus 1 from this, it should be 0. It cannot be 11 because we are saying 8 plus 2 itself is 10. So this, if we subtract anything from it, it cannot be 11. So we get b is equal to 9. Now if we see here, if we place 9 over here in the answer, we clearly see 5 plus 3 gives us 8 and a plus 3 just giving us b with no carry, since 9 plus 3 is 12. So this means a is 6. So a is 6 and b is 9 is the answer. So let's move on to the fourth question. We need to find out whether 221 is a prime or a composite number. So we first find out the square root of 221, which is more than 14. We know that the square of 14 is 196 and square of 15 is 225. So it lies between the square of 14 and 15. So we take the number 15 and we check its divisibility of 221 with all the prime numbers till 14. So the numbers till 14 are, the prime numbers till 14 are 2, 3, 5, 7 and 11, and we see that 221 is not divisible by any of these, but it is divisible by 13, which is again a prime number less than 15. So 221 is a composite number. Now moving on to the fifth question. We need to find the least number which when divided by 12, 15, 20 and 54 leaves a remainder 4 in each case. Now we know that the least number leaving 4 as the remainder when divided by all of these is 4 more than the LCM of the given numbers. 4 more than the LCM of these numbers. So if we first find out the LCM of these numbers, which comes out to be 540. So the least number which meets this criteria is 544. So now let's move on to the last question of the basic quiz. We need to find the number of factors of 3360, and we also need to find the product and sum and product of all the factors. So we'll first factorize this, and we can write 3360 as 2 raised to power 5 into 3 raised to power 1 into 5 raised to power 1 into 7 raised to power 1. Now the number of factors of this is, we know 1 more than this power, which is 6, multiplied by 1 more than this power, which is 2, multiplied by 1 more than this power, which is again 2, multiplied by 1 more than this power, which is again 2. So it comes out to be 6 into 2 into 2 into 2, that is 48 factors. Now let's find out the sum of the factors. Sum of the factors is given by 2 raised to power 1 more than its original power, which is 2 raised to power 6 minus 1, multiplied by 3 raised to power 2 minus 1, multiplied by 5 raised to power 2 minus 1, multiplied by 7 raised to power 2 minus 1, divide by the prime factors minus 1, which is 2 minus 1, 3 minus 1, 5 minus 1 and 7 minus 1. So that gives us 63 into 8 into 24 into 48 divide by 2 multiplied by 4 multiplied by 6. So this comes out to be 120196. 12096. So this is the sum of all the factors of 3360. Now let's now look at the product of the factors. Product of the factors is given by 3360 raised to the power the total number of factors divided by 2, which is 48 by 2. This comes out to be 3360 raised to power 24. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.